Hi and welcome to the last of my 5 video series on oscilloscopes with 100 MHz or more bandwidth and the price range from 50 to 100 euros or $52 to $104. The oscilloscope that I have here in this bag is the only one of the 5 reviewed in this video series that has 2 channels, and with that some more functions like the XY mode. I am really excited to review this oscilloscope since the last video of the DSO2512G that really raised the bar, and this one seems to have taken consideration and solved some of the problems that the one-channel version had. One problem easy to confirm that is solved is the cover. It's much better and I already took a peek. Now you also have more keys, passing from a total of 12 to 17. The size is also much bigger. It is one of the biggest handheld oscilloscopes of this 5 video series. I have to say that this oscilloscope wasn't sent for review and was bought with the revenue I got from the affiliate programs from AliExpress, Amazon or Banggood. Only possible because of you. Yes, you that use the Access affiliate links to do your shopping on these marketplaces. So, and once again, thank you for your support. Do you want to help also? It's easy, just use one of these Access links before paying on AliExpress, Amazon or Banggood and you'll be helping. It's exactly the same price to you, but your purchase will help me to maintain the channel, so thank you. Now, without further ado, let's see the highlight features. Okay, as usual, let's see what was delivered. This is the package where I received the oscilloscope. Let's take everything out. Okay, in the package it is delivered, I believe this probably is to P6100 probes. So those are 100 megahertz probes, as you can see here. It's the normal and standard probes that comes with the oscilloscope. We have also here 2 tips, normal screw for compensation. Yeah, with the probes already with the rings, very nice. With the probes comes also AV cable, and this one it's much bigger than the one that came with the with the 1511G. DSO1511G. It was very small, like something like, let me show you. Yeah, this is half a meter or less even. So yeah, this one it's much better. You can connect something with this. Okay, the oscilloscope comes in this semi-hard bag. It's pretty much standard in these small oscilloscopes that I received. Almost all of them are delivered in these bags. Let me open. So in here we have the USB Type-C cable for charging, the pins for the function generator, and we have also some cables too and crocodile clips to connect to the pins, and yeah, it gives a small extension. The normal user manual. Yeah, this one is for the DSO2512G, this model. It seems to be almost equal to the other one. We have here the function of the buttons. Yeah, the combinations of the buttons. Okay, index. And we have in the end, probably if it is equal to the other one, the technical specifications. So it says it's 100 megahertz oscilloscope. The resolution is the same, 320 pixels by 240, but the screen seems to be bigger. It has a 2.8 inches screen. The measurements are also 14 types. Yeah. And yeah, the rest is pretty much the same. We have also the, where it is, IT role. Let me search. Here it is, XY mode. It's also supported. And basically the rest is pretty much the same. Okay, move on. So let's take this out. The protective bag as always. Yeah, here it is. The first impressions from the outside show me that some of the problems the other one, the smallest one, had are already corrected. For example, now we have a single button. The OK selection button is here also. We have a button, I think this is for function generator. We will see in a bit. And the cover is much better. The rubber of this cover, it's good. It's resistant, as you see. We can push it. You will go back to the place. It will not allow the oscilloscope to slip. Yeah, it seems pretty well. I'm quite impressed with this comparing to the other one. And let me show you what I mean. Okay, this is the one channel version. As you can see, it's much smaller than this one. This is a big improvement in terms of size and some of the features. And the rubber of this one, it's a nonsense, to be honest. Look at this. It's all wrinkled and it doesn't make sense. Yeah. Back to this one. What we have in the bottom the AV output, the function generator output. I don't know what this is. I will have to see what this is. The charging port and also the connection to the PC for upgrade or remove the image on the oscilloscope. You can remove it from the memory of the oscilloscope. And yeah, 2 channels. Let me see if this kind of probe will function properly. Yeah, it will have a little difficulty to go in here, but it will work. This kind of piece of terminator, for example, I cannot, with a lot of difficulty to lock this, but it still goes. But look at the rubber as I do that. Yeah, looking at the probes that are delivered, it should be, it works pretty well. It's on the measure. It should be this circle, this circumference should be a little bit bigger to support this kind of probes that have a larger footprint in the circle. Okay, the first impressions are those. It has a nice screen. It's noticeable. You can notice this. Let's check it out. You have 5 centimeters more or less in this one. It's something like 2 inches for my American friends. This one, in terms of, it will be more or less 6 centimeters if you notice only the screen. Yeah, almost 6 centimeters, 2.5 inches. Well, the 2.4, it's something like this, 2.4 inches, yeah, like this. Yeah, anyway, you notice that it's bigger. Let me just zoom in so we can see better what I'm doing. In terms of operation, this is pretty similar with what we have in the DSO2512G. Let me just do a recap very fast of the keys. We have the directions keys, obviously with the select button, the auto and the run stop in here, the single. This one has a key for single. And we have also the menu key, save and access image list. Like you can save the waveform, and if you press long, you will access the menu list. just use the direction keys to navigate, and you can delete every image using the run stop like this. It doesn't even ask you if you want to delete, so be careful. To exit, just go to menu and you are done. In terms of buttons, you also have a new button for channel 1 and channel 2. Right now the channel 2 is disabled, and to enable you just press for a long period the channel 1, channel 2 button. As you can see, you now have new measures in the screen. To change between one channel or the other, you just press one time, a short time here, and you can see here on the top blinking which channel you are controlling. We now have a F1 function key that will activate the function generator. I will show you how this works in a bit. Just let me summarize this. So in terms of function generator, that's it. We have the millivolt and volt. Let me just start the function generator, my function generator. And we have the time domain in here. If you press once the power button, we'll have the opportunity to 50% center the channel 1 or channel 2. Let me show you. For example, if we move channel 1 offset 50%, okay, it will go to the center. And we have a lot of combinations that we can use also. For example, for channel 1 you have these ones to control coupling, and I think it's probe attenuation. Let me see. Okay, AC DC coupling, and the probe can be changed like this. Also for the channel 2, the same. As you can see, it's in green, and also the probe attenuation. Let me show you now the menu. It's pretty similar to what we had on DSO2512G, but this one has two options. I believe this is the same firmware. They only detect if it's only one oscilloscope or the other. It seems to be. So in here we have the options to control also the second channel. As you can see, the options change as we change in the keyboard. We have also the normal 14 measurements, but this time you can change here with this button which one you will activate for each channel, okay? And it will change the color to green when you are dealing with one channel or the other. In the trigger menu you have the auto normal. Also you have the trigger edge type raising or falling. You have the trigger level to be established auto or manual, and you can of course put the source of the trigger on channel 1 or channel 2. In the display menu you have also the persist, roll and mode. You have the persist 1 second or infinity. You have the roll mode on or off, and you can show the screen on normal or XY mode. I think that to activate XY mode, yes, it's just press power and OK, and you are able to activate the XY mode. I will show you working in a bit. Also in the auxiliary menu you can calibrate the oscilloscope and turn the FFT and function on and off with logarithmic, linear and music. And for last you have the set menu, where you can set the auto shutdown, the sound and the language. In this menu you have also the option to activate the USB to connect to the PC and to activate the AV. I will show you both of these options more ahead in the video. So let's start by showing some functions. I will take the menu out of the screen. Let's disable channel 2, and the first option, the first thing that I want to show you is the cursors. For cursors you have the vertical cursors. If you use the direction keys you can set the position of the left cursor, and if you use the functions keys but pressing the power button like this, you can set the right side cursor. Okay, the same for the horizontal cursors. If you just move with the keys, you set the top cursor. If you use the power in combination, you set the bottom cursor. And this works quite well, quite fast to respond. Let me just take this out of the screen. You have all the measures in the corner. Let me take out of the screen. Another thing that you have, this moves quite fast. If you want to move slowly, just press the power and move the key up and down. And if you press left or right, it will set the trigger. Right now it's auto, so it will always be on the middle. To be able to show you the next function, I will now connect the second probe, and I will connect that to my oscilloscope. Also, let me power the channel 2 on the oscilloscope. Yeah, right now we have 2 sine waves. Let me start the second channel, do auto. Okay, the second sine wave is with 94 megahertz. It's quite, let me just put 1 kilohertz. Okay, what I will do now is to show you the XY modes. We have a circle. If I change the frequency, we can change the figure types that we have on the screen. Let me just modulate the signal to animate it. Yeah, so we have here a modulated signal. I will see the deviation also. As you can see, we can have several figures only by changing the parameters in the screen, in the frequency. Yeah, so if I change, for example, now I'm sweeping, doing a sweep, it will do this kind of figure. Okay, so now let me change the frequency to animate this. Yeah, it works pretty well. Let me change this for something like 2 kilohertz and change the frequency also. Yeah, as you can see, the XY mode functions very well. The render is quite fast. We don't see any flicker in here, and yeah, quite happy with the way this works. So now let me show you the FFT, and for the FFT I will connect here this cable. This cable is connected directly to the music output or the headset output of my computer. So I will now start playing some music on the computer to show you what I want. We have the music signal in here, and I will now activate the menu, and let me see if I didn't change anything, and I will go to auxiliary and activate the log. Okay, you can see here the FFT working. This is the logarithmic. Let's see the linear, how it is. You have the linear here in the bottom also. It's quite simple, but it will do for most of the cases. And the one I want to show you is this one. As you can see, this is pretty cool. You have a bar spectrum analyzer for sounds, and yeah, quite amazing in this little oscilloscope. Okay, so moving on, already saw this function, and I will show you next the AV. Another cool feature that I want to show you, it's the connection to the AV. Just use the cable and insert it here in the AV connection. Don't get it wrong, already appeared on the screen. And to activate this, you just need to go here to the menu, last option, and just press run stop for a while until the AV is activated. When activated, it will appear in here AV, small letters. Let me show you in here, in the corner. And on the screen, you will have everything you need with a big size to be able to see it. My eyesight, it's not so good as it used to be. I have some difficulty right now to see what is written on this screen, but in this one, yeah, it will be pretty easy to read. So you have it in here. I already reviewed this on the 1511G, but I don't know if you saw that video. So let me show you again. And to activate this, you have always to be on the set menu, this one that has the auto shutdown and the sound, and press the run and stop. If you press, you can see that the line is moving. You have AV in here. Right now the AV is missing, and if I change the line, as you can see, the screen is not updated. It will always stay with the last image. I don't know why it's not always outputting, maybe to save the battery, because it's not a function that it's used so often. But anyway, you just need to press run and start, and you should have image updated in a bit. Yeah, that's it. Pretty cool stuff. Okay, I have here the image of the function generator. What I've done is to set up the channel 1, or in this case the channel 2, to be totally in sync with the frequency, amplitude and offset of the channel 1. So if I change, let me just change the frequency, something in channel 1, as you can see, channel 2 is immediately updated. What this means is that I will be able to update both channels at the same time. As you can see, let me just show you in here. And both channels will have exactly the same frequency and the same amplitude. Okay, let's start testing the bandwidth. Function generator is configured for IZ output in both channels, and this is input of 1 megaohm also. I've configured right now 100 kilohertz bandwidth with 1 volt VPP. So it's ideal to start testing the bandwidth of this device and to see how it handles the sine waves. We now have two sine waves, two identical sine waves, and this is pretty good. If I do something like the 50% OK, they are one on top of the other, and this is what we want. Okay. So right now I have everything that I need, and let's start testing the bandwidth. Okay, first value is 100 megahertz. As you can see, VPP 1 volt in channel 1, 1 volt and 1 in channel 2. A little bit of oscillation, but nothing really to worry about. From 1 kappa hertz, from 100 kappa hertz, I will change to 1 megahertz. I will do auto. Okay. We still have both lines one on top of the other. We cannot see any discrepancies. Very nice. Both channels detect 1 kappa hertz, and we have a little drop in voltage. Nothing too significant, but yeah, we did have a little droppage in voltage, more in channel 2 than in channel 1. Okay. From 1 megahertz, let's move to 10 megahertz. Okay, let's do an auto. In 10 megahertz, we already have a small change. In here, if you are able to notice, we see that the line is not completely over. Yeah, the voltage drop, it's not significant from the 1 megahertz. It detects perfectly the 10 megahertz bandwidth. Yeah, I should say that both signals are aligned in the function generator. I did align it before starting the test. Okay, so right now let's increase to 25 megahertz. Auto again. Okay, in 25 megahertz we start to see that the lines are not completely aligned, but still they are very similar. It detects perfectly the 25 megahertz. We have another small drop in voltage, still on 900, so yes, we are still good. Let's take this to 50 megahertz and see how it handles. Okay, I had a similar problem on the test before this, and it was my oscilloscope. So the first thing I will, it was my function generator. The first thing I will do is to reboot my function generator. Okay, we are back. Let me power channel 1 and channel 2. And yeah, I don't think this is from the frequency generator. Let me power off channel 2. Yeah, if I power off channel 2, this seems to be working. Might be something with triggering. No, it doesn't seem to. No, it went berserk. Let me manually change this to see what will be the frequency that will accept. Okay, 43, 49, 48 megahertz. 48 megahertz. If I use both channels with 50 megahertz, he will go bananas. Yeah, totally. But 52 megahertz, it seems to stabilize the signal. And more curious, the peak-to-peak will be higher than 1 volt. Let me just do auto to see if that is correct. Yes, it is. Okay. Weird results, but yeah. Okay, so let's move this to 75 megahertz. This time the fault was not my function generator. In 75 megahertz we do have a nice sine wave. It's well drawn. We have 2 channels. I don't know why he detected 25 megahertz. So this is not a good sign. Not at all. Let me take out the second channel. Yeah, without the second channel, we do have a drop in the signal, and also we detect perfectly the 25 megahertz. But if I activate the second channel, everything go berserk. Yeah, we cannot trust this with the second channel. The second channel can work up to 48 megahertz, not more. Even so, let's take this to 100 megahertz. It's the maximum of my function generator. Let's do auto and see what we have in here. Well, curiously we have something that it was a bug on the other one. Well, it's detecting kappa hertz. What? The voltage drop, it's complete. This is nuts. It's completely off the charts. Let me take the second channel off. In the other oscilloscope, after 95 megahertz, the oscilloscope went totally berserk. I'm talking about the 1511G, the predecessor of this one, and it seems that I have the same problem in here. As you can see in the camera, I will now change the voltage 1 megahertz by 1 megahertz to see when we will have a signal. Well, we have a signal here at 98 megahertz. The drop in voltage, it's it's very bad. This is not desirable. This is right now 99 megahertz, and we already have some problems in the signal over there. If I use the 100, yeah, it goes berserk. Well, since this is 100 megahertz, I do not have any problems with this signal on my Rigel. With the 100 megahertz from my Owen XDG 2100. If I use this on my Rigel, it will not have any problem. The Rigel right now it's with 300 megahertz bandwidth, and it has 2 gigasamples per second. I have to say that this only have 500 megasamples per second. I have to say that it's the same megasamples per second that this oscilloscope can capture. So maybe it needs more information, more samples per second, I don't know. Anyway, up to 98 we still have some kind of signal in the screen. It has a lot of jittery and flicker, but yeah, if I power the second channel, it will be bananas. Let me increase the signal. Well, if I do it like this without using the auto, we can have, yeah, this is kind of good news. If I use the auto, right now it seems to be working. 98 megahertz, 99, 100. 100, it's sadly, it's very bad. Okay, this is what, let me take let me change the time division, yeah, and okay, if I put in this time division, we can have something here. Yeah, I don't know, it doesn't seem 98 megahertz. He is able to handle it, not perfectly, this is totally out of phase, but yeah, we have both sine waves. And take it out. The second one, do auto. Yeah, the drop here is enormous, really. Let's do an adjust. I will drop the megahertz until we have 707 or some value near that to check it out. What is the frequency I get for the minus 3 dB. As you can see, I'm using 1 volt VPP in here. So let's do it. Okay. Seems to, okay. 94. It's about 94, 95 megahertz. It's about the same I had 60, yeah, 94 megahertz. In the function generator, it's outputting 94 megahertz. 94, 95, it's around that. Let me just increase one. If I increase to 95, it will go below 700 millivolts. It's a big drop. Yeah. Let me power the second channel and see if the voltage, with 2 channels at 95, we still have here the voltage. It will not identify the frequency. Yeah, but we cannot trust these specifications from the manufacturer. Even so, it's better or equal almost to this one. It's not better than this one, but it's better than the 3 other oscilloscopes that I reviewed before, the 1511G. I think that we are done for now. Let's test this with voltage to see how is the sensibility of this device in millivolts. Before testing the oscilloscope and the sensibility to the millivoltage, I will just check the reference values from my millivolt voltage board using my trustworthy unity. I will start by the 10 millivolts. It has 10.70. 20 millivolts. It has 25.30. Then I have the 50 millivolts with, let me check, 50.20. 100 millivolts with 100 on the spot. Now I have to change the scale. 200 millivolts, it's 248.6. 500 millivolts, it's 502.5, something like that. Yeah. And 1 volt, it is a bit lower, it's 989.2 millivolts. And 2.5 volts, it's 2.489. And finally, this one, it's to forget, it's the 5 volts, it's not working in this board. Maybe it's solved in the version 2. So we have the values. In the oscilloscope, this one should give something like 4 volts. We'll see. Now it's the time to talk about this video sponsor, Zeeweii. I always use Zeeweii for creating my boards with a professional factory quality, as you saw in my millivolt voltage reference board. It is very cheap to manufacture your PCBs on Zeeweii. You can manufacture 10 PCBs for only $5. How awesome is this? And it is pretty easy also. Just insert here the PCB dimensions and you'll have an instant code. So when you want a PCB, visit Zeeweii to get your code, and if it is your first time ordering from Zeeweii, you can use our access link for a $5 credit. And don't forget, they also have component assembly service, 3D printing service, and much more. Well, I have the probe configured for one time. Also the oscilloscope. I will do auto to clear, and let's start with 10 millivolts to see what we have here. Okay, it doesn't seem to detect. Let me do auto. It detects RMS 10 millivolts. Okay, let me use the claw to, it will be better. Yeah, like this. So I have here 10 millivolts, very stable signal, very well. But yeah, it's between 10 and 12 and 11 millivolts, so maybe it is in the 2%, a little stretch, but yeah. 25.6, okay, also good. Very precise, yeah, very precise, the voltage. So let's go again. (51) RMS 50.3. I think the reference value is something around this also. What a champion. Okay, we need to do auto to set 100 meg. This one is on the spot, 100 millivolts, RMS 100, 101, and mean, yeah, it's almost there. It's inside the 2% error, the mean. Let's see again, 250 auto, 252, 248. If you remember, the value was 248.9, so also good. Let me take this and go up to 500. 500, let's do an auto again. This one was 489, no, 502. So the RMS is nearer than the real value. Yeah, but close enough. Let's take this to 1 volt, and for 1 volt the value was 989, I believe. 992, 77 in the mean. This is the average. Okay, take this to 2.5 volts. 2.5, yeah, almost 248. The mean is the value that we have. This one is 248.9, I think. And last, it will be the 5 volts. That it's not 5 volts, it's something else. It's 4 something. What? Whoa, this is awesome. I have a problem with these 5 volts. My bench multimeter, it's a Siglent, the SDM 3045X, detects here 5 volts, but my every multimeter, the handheld multimeter that I have, doesn't detect here the 5 volts. So I don't know, this is the first oscilloscope I think that I use this board that detects here in RMS 5 volts and 4.96 in mean or average. So this is the closest I got from my Siglent desktop or bench multimeter. Amazing. I don't know why this pin that comes directly from the L7805, the output of 5 volts directly to here, has these different values. Maybe it's because of how the circuit was designed. I had a mistake also, couldn't use the capacitors in here. But yeah, it detected 5 volts. Awesome. Okay, let's move on. I want to show you 2 more things. The first one is how to upgrade your oscilloscope, and for that you just need your USB cable. Start the oscilloscope by powering the power button and MV at the same time, and it will appear this weird screen. It has red letters. It's really hard to read what is written there, but basically what they are telling you is now connect the USB cable, then copy the firmware to UDisk. UDisk is a drive that will appear on your computer. Disconnect USB and press OK button to upgrade. That's the only thing you need to do to upgrade this device. You connect here. This will have to be connected to the computer. After, it will appear a drive. Copy the bin file over there, disconnect the cable and press OK. That's it, and you will be able to upgrade the firmware. While the upgrade process is running, it will appear here a progress bar of this size. And yeah, I will not do it, but it's how you do it if you need it to do. Another thing that I want to show you is how you can take the image that are saved in this oscilloscope to the PC. You cannot put something in here, but you can take the image out. And for that, let's power the oscilloscope off and start it again. Oops, one more time. Okay, we are powering it up. To take the image of the oscilloscope, let me first see if we have any image in here. Yeah, we don't. Just press save. Okay, another. And right now we should have 2 images. Yeah. And if you want to access those images, it's pretty simple. Just go to menu, go to the last menu, and you just need to press for a while the NS. This will appear, and if you have the cable connected like this, a new drive will appear on the PC and you are able to copy the files to your computer. When finished copying everything, you have to power it down to leave this screen. Okay, just press in here. I forgot to show this on my previous video, but the process is exactly the same for the 1511. Okay, that's it. Teardown time. Well, for first impressions, we have here a pretty big battery. I don't know how much milliamps hour this is. Let me see the manual. The manual says it's a 4000 milliamps hour battery. Yeah, it's pretty big. And first impressions, it seems like we have some SD card here. I don't know what this is. Okay, let me zoom in and we'll find out. Okay, let's start by this side. In this side we have two octocouplers or photocouplers. Those are Cosmos 240S. So in the specs they call it high voltage photo MOS relay, this one and this one. We also have right now, because we have two channels, everything is duplicated basically, but we also have the same subminiature signal relay that we had on the DSO1511. This is a 2 amps relay. So moving on to the top, we still have those two ICs scratched or polished or whatever, laser burned, whatever, it doesn't matter. I still think this is something like a multiplexer or the multiplexer or 823 line, whatever, something like that. Let me see what else. Moving on, we still have here two amplifiers. The first duplicated here and here. The first one is the analog devices 1 GHz low distortion amplifier with ultra wide speed, and the second one it's the LVM358. It's a general purpose low voltage rail-to-rail output amplifier. We have two sets of them. Also in here we have several units of this 74HC595D. This is a 8-bit serial in or serial or parallel out shift register with output latches. So we have two units, and I think we have one more here in the back. Yep, that's it. A total of 3 units of this IC. We still have this, I think this is a ADC, I don't know. Tell me you guys what you think. In here also scratch, and the FPGA, I believe it's this one, it's also scratch. So don't know what IC is this. We still have in here the all-winner F1C100S. This is a 70p HD multimedia processor. I already talked about it on the previous review of the DSO1511G. It also had this processor. This supports H.265 video decoding, video encoding, MPEG video encoding, video decoding. It has a lot of functions for connectivity, 32 megabytes DDR1. It has codecs. Well, it's a multimedia processor with a lot of stuff in it. It's a very nice unit, and I believe this is the reason we have a AV output in this oscilloscope. So moving to the top, we have in here a Puya P25 Key 32SH. Is this little guy in here. This is a ultra low power 32 megabit serial multi-flash memory. So I think that's where they store all the settings. Something new in here is this. It seems to be a SD card slot. It's empty, but it seems to be a SD card slot. I don't know. I already saw a newer version of this board that had here a metal protective shield for interference or something like that. So, as I told you, we still have these in here scratched. And yeah, under here, I'm almost sure that we have a TP4056 Li-ion battery manager. Almost, it's what they used almost in every device like this. Here it is, the complete board. Now I will close this and do the conclusion. As I was expecting, for the preview I got with the one-channel version DSO1511G, this oscilloscope is amazing. I know, it has flaws. We still have the recurring problem of the announced bandwidth being higher than the one I get in the tests, but even so, I managed to have 700 and something millivolt signal at 94 MHz. But I must say that the signal was much more jittery than the one I got with the one-channel version. And you can use these more or less up to 50 MHz. After that, it's stretching out. Some of the problems detected in the DSO1511G were fixed, like the rubber cover, much better now. The problem with the 100 MHz on the display that showed 0 MHz, some additional keys like the key for the function generator and the single trigger, the OK button. I'm talking about small things, but that will improve the overall experience. This oscilloscope, the DSO2512G, cost me around 85 euros. These will be $88 or 72 pounds. We are here starting to enter in a zone where you almost can get the Owen 70 MHz handheld for almost the same price or some bucks more, but have also some options in the Handtech. Forget the 120 MHz of the SigPeak DSO2512G. They are not here. So maybe evaluate something more expensive for more 30 or 40 euros might not be a bad decision, considering that you'll have a product with support. That is one of the problems of SigPeak. SigPeak, as mentioned in the previous video, doesn't have internet presence. You have only one YouTube channel with almost no content and nearly zero description in the videos. Even so, you can get from one or two videos that the channel is from the creators of the SigPeak and have the links for the new firmware, at least for the DSO1511G model. Now that you know the limitations, if this oscilloscope is within your requirements, may be a good purchase. Many people can't or won't spend more money than this, and you'll have a very complete oscilloscope for a really attractive price. Don't forget that this model has a function generator, video output FFT with 3 modes, cursors, XY modes, 14 measurement values, so a lot of stuff in the price. Is it perfect? No, far from it. But you can get a lot of stuff for a very accessible price. The main problem is the bandwidth, and if the bandwidth is enough for you, it will be a great tool. The millivolt test passed with flying colors, almost matching every value of my millivolt voltage reference board. If you decide that this oscilloscope is a fit for you and decide to buy one, I will be really grateful if you help me to develop the channel by using the affiliate access links on the screen or the product links in the description. Your help is really important. To wrap it up, will I buy it? Yes, for my projects as a hobbyist will be enough, and will be enough for most people that need to learn and won't require a razor-sharp precision. For that, the appropriate tool is in another brand and price range. If this video was useful to you in any way, please slap that like button, and if you haven't already, please subscribe and hit that bell to activate all notifications and be the first one to be notified whenever I upload a new video. That's it for today. Thank you for watching this video and staying with me until the end. I hope to see you in my next video. Cheers!